Imagine a time before time. Darkness reigns. The universe is a vast, empty canvas, waiting for the first brushstroke of creation. Suddenly, a vast cloud of gas and dust, a nebula, stirs. This nebula, a cosmic nursery, is the birthplace of stars. It's a chaotic ballet of particles, remnants of ancient stars swirling in the vast cosmic expanse. These particles, once part of long-dead stars, now dance in a cosmic waltz. Gravity, the invisible conductor, begins to orchestrate. It pulls the particles together, guiding them in a cosmic choreography that will lead to the birth of a new star. The cloud collapses inward, particles colliding, generating heat. This heat, born from the friction of countless collisions, is the spark of creation. At the heart of this maelstrom, a star ignites, our sun. This newborn star is a beacon of light in the darkness, a new beginning. The newborn sun's fiery breath pushes outwards, scattering remaining gas and dust. Yet gravity's pull persists, drawing the scattered particles into a new dance. Around the sun, a swirling disk forms, a cosmic nursery where planets will eventually be born. This disk, rich with the building blocks of planets, is a cradle of potential. This is the dawn of our solar system, a chaotic yet beautiful symphony of creation, some 4.6 billion years ago. From this swirling chaos, planets, moons, and countless other celestial bodies will emerge, each with its own story to tell. Within the swirling disk, a delicate dance begins. Dust grains drawn together by electrostatic forces clump together. These clumps, mere millimeters across, are the seeds of planets. As they orbit the sun, they sweep up more dust and gas, growing larger. These growing bodies, now kilometers across, are planetesimals, the building blocks of planets. Collisions are frequent, some destructive, others constructive. Larger planetesimals, with their stronger gravity, attract smaller ones, growing ever larger. Over millions of years, this chaotic dance sculpts the solar system, leaving behind fewer but much larger bodies. Among them, our young Earth begins to take shape. Imagine Earth in its infancy, a fiery, molten world. Constant bombardment by asteroids and comets generates intense heat. Radioactive decay within its core adds to the inferno. The planet is a churning ocean of magma, a crucible where rock melts and reforms. Yet within this chaos, order begins to emerge. Heavy elements like iron and nickel sink towards the center, forming Earth's core. Lighter elements like silicon and oxygen rise to the surface. This process, called differentiation, shapes the planet's internal structure, creating the core, mantle, and crust that define our world today. Earth, still in its fiery youth, experiences a cataclysmic event. A Mars-sized object named Theia collides with our planet in a colossal impact. The energy released is unimaginable, vaporizing rock and flinging molten debris into space. Earth's surface is reshaped, its axis tilted, forever altering its destiny. From the debris of this cosmic collision, a new celestial body emerges. Bound by gravity, the ejected material coalesces, forming a ring around our wounded planet. This ring over time clumps together, eventually forming the Moon, our constant companion in the vastness of space. The fiery chaos gradually subsides. Earth, no longer subjected to constant bombardment, begins to cool. The molten surface solidifies, forming the first solid crust. Water vapor, trapped within the planet's interior, escapes through volcanic eruptions, forming a thick, steamy atmosphere. As temperatures continue to drop, the water vapor condenses, forming vast clouds that unleash torrential rains. Over eons, these rains fill the planet's lowlands, forming the first oceans. These primordial seas, teeming with dissolved minerals from the young Earth, will become the cradle of life. Section 6. The Hadean Eon, a time of turmoil and transformation. The Hadean Eon, aptly named after the underworld, was a time of intense geological activity. Volcanoes erupted with ferocious power, spewing molten rock and gases into the atmosphere. The young, thin crust was constantly reshaped by tectonic forces. Yet, amidst this turmoil, life found a foothold. Within the primordial soup of the early oceans, a remarkable transformation occurred. Simple organic molecules, the building blocks of life, assembled. Driven by energy from the sun and geothermal vents, these molecules formed increasingly complex structures, eventually leading to the emergence of the first single-celled organisms. Section 7. The emergence of life. from primordial soup to single cells. The first life on Earth was simple single-celled organisms known as prokaryotes. These hardy life forms thrived in the harsh conditions of the early Earth, obtaining energy from chemicals in their environment. Over millions of years, evolution sculpted these early life forms. Photosynthesis evolved, allowing organisms to harness the power of sunlight to create energy. This process released oxygen into the atmosphere, gradually transforming it from a toxic mix to the life-sustaining air we breathe today. This marked a turning point in Earth's history, paving the way for the evolution of more complex life. Section 8. A planet in constant flux, shaping Earth's destiny. The Earth we know today is a far cry from the fiery, molten world of its infancy. Billions of years ago, our planet was a seething mass of molten rock, constantly bombarded by asteroids and comets. Volcanic eruptions were a common sight, shaping the early landscape and atmosphere. Continents have drifted across its surface, driven by the relentless movement of tectonic plates. This process, known as continental drift, has been responsible for the formation and breakup of supercontinents over millions of years. Oceans have risen and fallen, influenced by climatic changes and tectonic activity. These fluctuations have dramatically altered coastlines and marine habitats, impacting the evolution of life on Earth. Life has diversified into a breathtaking array of forms, from the simplest microorganisms to the most complex multicellular organisms. This incredible biodiversity is a testament to the adaptability and resilience of life on our ever-changing planet. Yet the forces that shaped our planet billions of years ago are still at work today. The same geological processes that formed the Earth continue to mold its surface, creating mountains, valleys, and other landforms. Plate tectonics continue to reshape the continents, driving the movement of land masses and the formation of new geological features. This dynamic process is a key factor in the ongoing evolution of our planet. Driving earthquakes and volcanic eruptions, tectonic activity is a powerful force that can have both destructive and creative effects. These natural events play a crucial role in the recycling of Earth's materials and the creation of new land. The atmosphere and oceans regulate our climate, creating the conditions necessary for life to thrive. Through complex interactions, they help maintain a stable environment, supporting a delicate balance of life. Earth's ecosystems are interconnected and interdependent. The health of one ecosystem can have far-reaching effects on others, highlighting the importance of preserving biodiversity. Understanding Earth's formation is not just a journey into the past, but a key to understanding the present and future of our planet. By studying the history of our planet, we can gain insights into the processes that continue to shape it today, but a key to understanding the present and future of our planet. This knowledge is essential for addressing the challenges we face, from climate change to natural disasters, and for ensuring a sustainable future for all life on Earth. Section 9. Looking back to understand the present, Earth's enduring legacy. Looking back over 4.6 billion years allows us to appreciate the incredible journey our planet has taken. From its fiery beginnings to the lush, life-sustaining world we know today, Earth's history is a testament to the power of time and transformation. From a swirling cloud of dust and gas to a vibrant world teeming with life, Earth's story is one of constant change, adaptation, and resilience. The early Earth was a hostile environment, with volcanic eruptions and meteor impacts shaping its surface. Over millions of years, these violent processes gave way to the formation of oceans and continents, setting the stage for the emergence of life. As we face the challenges of the future, understanding our planet's past provides valuable lessons for our own survival. The geological record, with its layers of rock and fossilized remains, tells a story of mass extinctions and recoveries, of climate shifts and the adaptability of life. By studying these patterns, scientists can predict potential future changes and help us prepare for them. The Earth is a testament to the power of time and the remarkable potential of even the most inhospitable beginnings. From the barren, molten surface of its youth to the diverse ecosystems that now cover its surface, our planet's journey is a story of hope and resilience. Each epoch, each era has contributed to the rich tapestry of life we see today. By studying its formation, we gain a deeper appreciation for the delicate balance that sustains life and the responsibility we have to protect our planet for generations to come. The Earth's atmosphere, its oceans, and its landforms all work in harmony to create the conditions necessary for life. As stewards of this incredible planet, it is our duty to ensure that future generations can continue to marvel at its beauty and benefit from its resources.